If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture where we are building concepts for JEE Main and Advanced level in coordinate geometry circles. So today we will discuss about radical axis. What do you mean by radical axis of two circles, and then we will see its application in finding common chord and common tangents, and what is radical circle. Okay, then let's see this. Okay, the topic is radical axis of two circles. So what does radical axis means? So before going to radical axis, let us find a condition for which we will have two equal tangents drawn to two different circles from a point. Suppose you have a circle this and you have another circle this. So you have a point this, and from this point you draw tangent to this line, this and this, and both these tangents are equal. Suppose it is PT1, PT2. So how many such points are possible? There are infinite points are possible, and if you will see, then you can see that you will find if it is okay, my drawing is not okay, you will find, and this will come to a straight line. We will derive this one. Okay, first let us find, suppose a point is given to you, Px1, y1, and under what condition, and this circle is given to me, this circle is also given. Under what condition this Pt1 is equal to Pt2? So let us derive the condition first, then we will see the locus of P. How many P's are, how many such points are possible. Okay, so what is given to me, that is always very important for starting any article. I told you, one circle is given to you, another circle is given to you, and a point is given to you P. So what is my intention? My intention is to make these two equal. I have to find a condition when Pt1 is equal to Pt2. So how to find the length of a tangent from external point? We have already solved. It is root power of a circle, root S1. So root S1. What is this? Root S1. Again same point, you will put it here. This is the power of the point, then root. The power of the point I will put it here, then root. This is the length of tangent we have already derived in length of tangent article. So if you take square and then if you cancel out x1 square, finally you will get this one. Ultimately this one, you can also write it this minus this. If you deduct this two, you can find this, or s1 minus s2 or s2 minus s1. If you take minus common, then it is s2 minus s1. So this is the condition. You can say this is the condition. Condition to have equal tangent drawn from two different circles. Equal tangent drawn to two different. So if you satisfy this condition, if your point satisfies x1, if your point x1 y1 satisfies this condition, then the tangent's length will be equal as per this one. Okay, so we found the condition. So that means you can have lots of x1 y1, because you have only one equation. You can put x1 y1, lots of x1 y1 you can put in this equation, which can satisfy this equation. If you suppose if it is 2x1 plus 3y1 is equal to 4, you can put 0, 3. Suppose after doing this one, g1, g2, everything, you got this one, 2x1 plus 3y1 plus 4 equal to 0. Now you can do it in so many ways. If it is equal to 0, then it would have been minus 3 by 4. If it is 0, then you can have minus 2. So lots of one x1 y1, you can have this one, minus 4 by 3. If you put, then it will be 0. 1 you can have 0 comma minus 2. So there are lots of points you can, because it is an equation of line, you can say. Okay, so let us now find the locus of all points for which the length will be equal. That is known as radical axis. So this is the definition: locus of all points from which equal tangents can be drawn. The all possible points P for which the equal tangents can be drawn, that is known as the locus of P, that is known as the radical axis. So let us say P is now because I want to find the locus of P, I am not considering x1 or y1. Let me take Pxy. So if it is xy, any point, any general point xy, and you find this distance Px1, Px2, Pt1, Pt2, and then you make them equal, you will find this condition only, because this is the condition. In place of x1, y1, I am putting xy. So if this condition satisfies, then the tangents will be always equal. So this is the condition. What does this represent? This represents a straight line. So that is known as radical axis, or which is also known as, this equation can be also written as s2 minus s1 or s1 minus s2. Now by seeing this, can you recall anything what we have studied till now? If you have seen the earlier videos, you should have recalled this. We have already seen in basic level, common chord, common tangent equation. I told you we will explain it in detail in JEE Main and intermediate level in radical axis. So here we are explaining it in details. That in basic level we have seen only just formula, just two cases, but it is more general cases. From here you will understand now more clearly. So radical axis is perpendicular to the line joining the centers. Now you see this line. This is the radical axis. This is the equation of the radical axis. Now the slope of this one and the slope of this AB, I am not writing C1 C2, otherwise you will get confused with this C1 C2. Let the centers are AB, so its coordinate is G1 F1 minus G1 F1, its coordinate is minus G2 F2 from this equation. So what is the slope of this line and the slope of this line? If you multiply these two, you will get minus 1. Let us see whether we are getting minus 1 or not. Because they are minus 1, that's why I am saying that there it is perpendicular to the line joining the centers. So what is the slope of this one? Slope of this one, y2 minus y1, that is either f1 minus f2 or f2 minus h1, whatever you can take by this one. This is the slope of line AB. And what is the slope of this? You can make it y equal to something. So this divided by this divided by this. If you take product, you will see it is minus 1. That's why it is perpendicular to the joining the center. It may bisect, it may not bisect this line, but it will be perpendicular to this line. Radical axis is perpendicular to this C1 C2. Now you can see if two circles touch each other, that is your basic level where we say it is the equation of common tangent. They can touch externally, they can touch internally. Two cases are possible. Then the common tangent, this is the tangent which is common, okay, at the point of contact. Then radical axis is nothing but this line itself. From this line, if you draw tangents, it will be always equal because it is the common tangent, you can say. So common tangent means you can say from that point because there is no distance now. If you come to this, so this line will give you the radical axis. So you can see it in this way also. Suppose these two touched each other. So if you come to this point, from this point, what is the distance of this circle at this point? 0. From this point it is 0. So it is equal. So that means here in this line itself, whatever, and it should be perpendicular to this. So it is perpendicular to this means tangent. So you can say it is tangent, that's why. So because radical axis cannot go through a circle, it cannot go inside the circle. If it is good inside the circle, then you cannot draw tangent from this to this circle. Because from radical axis you can draw tangent to both the circles. So if it cannot go inside and if it has to perpendicular, so it has to go through this. So this is the common tangent. So that's why the radical axis became the common tangent equation. So in basic level, while we are writing the equations for common tangent, we write it S2 minus S1 equal to 0. And here the same concept here also. Now if the two circles are intersect, now they are intersecting this one. Now what is your radical axis? So your radical axis is here now this common chord, because this, suppose they are intersecting now, so this becomes your radical axis. So from here to here you cannot draw tangent, that is different, but from here, from outside, you can draw the tangents. So from here these tangents will be equal. You can prove it, but I am not going for proof, but you can easily do it. Or you can say this is the perpendicular to this line. So if you come to this point, so tangent from this point to this circle is 0, tangent from this point to this circle is 0. Both are equal. Here also equal. So if these two has to be in this line, so these two has to be chord and it has to be 90 degree, because you know center, if you join center, this one we have already seen, the radical axis is perpendicular to this. So when basic level we are studying what is the equation of the common chord, then we write it common chord equation S2 minus S1 equal to 0. So now we can understand from where it is coming, because common chord is nothing but radical axis and radical axis is S2 minus S1. So radical axis is general approach and it is specific. For this case it becomes common tangent, here it becomes common chord. So if you remember this one, you can apply in specific case. So now some conclusion in radical axis. Suppose there are 3 circles now, so you can take 2 at a time and you can draw the radical axis. 1, 2, 3. Suppose you have 3 circles, 1, 2 and then 3. So you can draw radical axis. This is the radical axis of R1, 2. This is the radical axis of 2, 3. This is the radical. All 3 are concurrent. They always pass through a same point. That is the geometrical understanding. The radical axis of 3 circles taken in pair are concurrent, and the intersection point of these 3 is known as the radical center of the 3 circles. This is known as the radical center of these 3 circles. Okay, now if you see this one, the radical axis need not always pass through the midpoint of the center joining the lines. This one I have told you, it should not be, it is not that every time it will be midpoint. You can see here it is not the midpoint. Midpoint is here, it is shifted here. If it is more smaller, then it will go more shifted that side. That depends on the situation, but it will be 90 degree, that is for sure. So it may bisect, it may not bisect, but you cannot say it will bisect. It is not a theorem. So radical axis bisect the common tangent, but it will bisect the common tangent. If you have a common tangent here, then it will bisect. Obviously it should bisect, because If you draw a common tangent, so it is P, so PT1 is equal to PT2. What do you have learned from radical axis? Any point from radical axis, you draw tangent to both this line, they should be equal. So because it is in the radical axis, this P, so if you draw this line, if you draw this line, so both should be equal. That means P is bisecting this tangent. So that's why it is saying that your radical axis bisect the common tangent between these two. You can see this one also. So this is the point P from which you get drawing tangent here. Both these should be equal because it is in radical axis. So radical axis bisects the common tangent between them. And which circles don't have radical axis? Concentric circles. If you have a concentric circles, this one, same center, then you cannot have radical axis, because you cannot have lines point, because if you take point here, so if this distance and this distance will never be equal, you can see. And if you come inside, you cannot draw tangent for this line. So you cannot be inside, you cannot be this inside, because for tangent you have to be outside. So you have to draw tangent for both, you have to be outside both. From outside both, if this length is this length only, obviously more. So for concentric circles, you don't have radical axis. If you like the video, then press the like button and please give your valuable comments in the comment section.